to discuss the end behavior of our graph, we need to first look at the degree of the polynomial. The degree is 3. Since the degree is 3 and the leading coefficient is positive, it's of this general form. Remember the cubic function? So it looks something like that. It may do some crazy stuff in the middle, but that's the basic end behavior of our graph. So you can see that as x goes to negative infinity, y goes to negative infinity, correct? As x goes this way, y goes this way. So as x approaches negative infinity, y approaches negative infinity. As x goes to positive infinity, so as x is going this way, y is going up. So as x approaches infinity, y approaches infinity. That is our end behavior. You can also summarize it by saying down on the left and up on the right. That's just a summary of this end behavior. Okay, now we want to find the rational zeros. Remember, we just did that on the last page. That's finding your p's and q's. So p in this problem is your 6 and q is your 2. So now we need to write all the factors of 6. Remember, you have to do your plus or minus because it could be 1 times 6 or negative 1 times negative 6. So we just cover them all by doing plus or minus. The factors of 6 are 1, 2, 3, and 6. Factors of 2 would be positive and negative 1 and 2. Now we have to list all of our p over q's. Positive and negative. We have 1 over 1 and 1 over 2. We have 2 over 1 and 2 over 2. 2 over 2 is 1, and we already have that one, so we don't have to list it again. We have 3 over 1 and 3 over 2. We have 6 over 1 and 6 over 2. 6 over 1, 6 over 2 is 3, and we already have that one. So this is a list of the possible rational zeros. The next thing we need to do is write this polynomial in factored form. Well, I haven't really shown you how to do that yet. So we take our list of possible rational zeros and we test them. You remember in the previous video we said if the remainder is 0, then that number is a 0 of our function. Well, let's test them. What I'm going to do is I always start with the very first one, and I start with the positive. So let's just store 1 stow x enter. Then I go up there and enter my function. X cubed plus x squared. Okay, I think that's right. So I found p of 1 was negative 4. That means when I plug this in, I get a negative 4. If I don't get a 0, then that's not a 0 of my polynomial. I keep going. I always just test the very next one. So I test positive 1, then negative 1, then positive 1/2, then negative 1/2. So now what I'm going to do is store negative 1. I'm going to recall the function. This time I get 18. That doesn't work. So I move to the next one, which is 1/2. So 1/2 stow x enter. Oh, I get 0 this time. Once I get a 0, I stop. Now I know that you can just keep testing these until you find them all. That is not the process that I want you to follow for this class. Okay? Once you find a 0, you stop, you do synthetic division. So 1/2 goes on the outside. On the inside, we put our coefficients. 3, 2, 1, 0. We're not missing any terms. Bring the first one down. Half of 2 is 1. Add. Half of 2 is 1. Add. Half of negative 12 is negative 6, and we add. If we don't get 0, we know something is wrong because we found it was 0 on this side. Okay, so that has to be 0, otherwise this whole thing doesn't work. Reduce your leading exponent by 1 and write what you have in factored form. So we have this one. So we have x minus that 1/2. It's always x minus whatever that number is. And then we have this part of our polynomial. Now, if you'll notice, we can actually factor a 2 out of this, right? Let's go ahead and do that. I'm just going to put it in the front of everything. We factor that 2 out of here. We have x squared plus x minus 6. In this next step, I'm going to do 2 things. I'm going to multiply this 2 times each of these, mainly because I don't want this fraction in here. And I'm going to factor this part right here. So p of x is equal to 2x, 2 times negative 1/2 is negative 1. Factors of negative 6 that add up to negative 1 would be a positive 1, would be a positive 3 and a negative 2. So the instructions were to write the polynomial in factored form. We just did that. This is the factored form of our polynomial. We're supposed to find all the real and imaginary zeros. We found 1 0 here. It was 1/2. By the way, that came from this factor. So to find the rest of them, we need to set the other 2 factors equal to 0. And solve. So these are our 3 zeros. They all occurred 1 time, so all have multiplicity 1, which means they are all cross points. So all of those little things that we've been learning about polynomials, they're culminating into this one lesson. Okay, we're supposed to find the y-intercept. Remember, to find the y-intercept, you let x equal 0. Well, let's go back up to our function. If x is 0, that's 0, that's 0, and that's 0. The only thing left is 6, right? So our y-intercept is going to be 6. You would write that as the point 0, 6. We're supposed to sketch the graph of our function now. So let's see what we can do. We have several points going on. First of all, your zeros give you your x-intercepts. So your x-intercepts are the points 1/2 0, 2 0, and negative 3 0. So you can plot these 3 points and your y-intercept, and you also know your end behavior. Okay, so let's go ahead and plot all the points. We have 1/2 0, we have 2 0, negative 3 0, and 0 6, something like that. We know that this makes that shape, so it goes down on the left and it goes up on the right. All of these are cross points, so our function goes across the x-axis at each of those points. Now keep in mind, this could go really, really high and really, really low. It could go off the paper, or it could just go right there for all I know. I didn't get any more points to show me how to draw this more exact. I just want to get a general shape. So if this is how you work this on a test, it will be all good.